So the first thing that I always read in my comments, really no exception, is either going to be capacitors or ferrites. Now, there is a funny graphic that correlates the amount of ferrites used to the skills of the design engineer. The more ferrites you see, the less skilled the design engineer is. Ferrites are oftentimes a last-ditch effort to gain a few dB of freedom when some product has failed. Never at any point should ferrites be your primary EMC solution. But since I knew I'm going to get that comment anyway, try a ferrite, I thought, well, let's try a ferrite. And here's the measurement with the ferrite. You can see that there's now two traces. You see it here where there's actually differences. There's a bright purple, bright green, and a darker purple and a darker green. The darker one is the old without the ferrite, and the lower one is the darker one is the old measurement, and the brighter one is the current measure. So you see there's almost no difference, almost nothing except up here. And yeah, that didn't help us at all. Right, okay, I was just stunned for a second what I wanted to show. Now, let me show you the advantage. And yes, we'll get to solve this problem, but first we're going to look at something different. I mentioned earlier that I prefer using two lizens because it gives us some advantages. And the advantage is being able to separate the kind of noise we're dealing with. What I'm using here is a listen mate, which is also from the company TechBox that produces these listens. And both listens are now connected to the listen mate. And now I have two outputs, differential mode and common mode. I hope everyone's familiar with common mode and differential mode, but a very brief recap is signals, the way we usually know them and learn them in school and university, travel in opposite directions. Like here, you'd have the positive supply going that way and coming back that way. At least from the technical standpoint, I know electrons flow that way and come back that way. Common mode would be both signals, like noise coming from over here, traveling on both lines, same direction, same phase, same amplitude. And so this is separating common mode and differential mode, so we can measure them independently. Yes, here's the drawing. The listen mate is the newer version. I'm not using it, but the graph is the same. Two listens, listen mate, spectrum analyzer, and you can switch between differential mode and common mode. And here I have the differential mode. So that part of the noise that is traveling in opposite directions on the line. And over here, I have the common mode. So the amount of noise that's traveling in the same direction on the wires. You see over here, these small peaks on the common mode. And if you remember the picture from beforehand, the only place where we had a difference here with the ferrite was exactly those locations. It's because ferrites suppress common mode, but that's not our main problem. Our main problem is differential mode, which is a shame because I wanted to show some sort of fancy filter, but we're not going to get a fancy filter, I'm afraid. So, the KISS principle, keep it simple, stupid. Two inductors. They are 470 microhenry inductors. And just out of, for simplicity, I put them right in front of the listens. Of course, I could have hooked them up at the input terminals of the equipment on the test. And that's, of course, where you would place them if you were to redesign an equipment under test. But just for this purpose, I put them right here. Remeasuring, these are still CISPR 25 class 3 limits. And look at that. That's all we need. Like I said, it's a shame because I was kind of hopeful that I needed higher order filters, but I don't. That's it. Problem solved. Now we can go for compliance testing. Now,